So today we're going to talk about solving linear equations but with the variable, that's an E, on both sides. So this is a particular type of problem, and I am Professor G. And so thank you for taking the time to watch this today. So what we're going to do is we're going to start off with an equation that looks like this. 3x plus 7 equals 5x plus 1, right? Now as you'll notice, there's an x over here and there's an x over here, right? So normally we just start solving for the variable. So if I just wanted to solve for the variable over here, you undo your addition and subtraction first, right? So let's just say I'm trying to solve for this x right here. So I subtract 7 from both sides, and I get 3x is equal to 5x minus 6, right? Because plus 1 minus 7 is negative 6. And then of course we undo our multiplication with division. And so I'm going to divide this side by 3, and so then I have to divide this whole side by 3. And I get x is equal to 5x minus 6 all over 3. And I go, well, what's x? Because there's all this gobbledygook over here. You know, there's another x in here with all this other stuff being done to it. This one's become a mess, even though I've taken care of this one. Alright, well, what if I chose the other one? Alright, so let's try that. So here's our original problem that we've been working on. And now instead of doing the other side, let's focus our attention on this x right here. So I'm still going to undo my additions and subtractions first. And this is a plus 1, so it's additive inverse is negative 1. And whatever I do on the right hand side, I have to do on the left hand side. Right? That's the equity principle. That keeps everything nice and balanced. And so you end up with 3x plus 6 is equal to 5x. And again, remember I said we're going to undo our multiplication with division, because that's its inverse operation. And so you divide by 5, and you divide by 5, and you end up with 3x plus 6 over 5 is equal to x. And we're in the same boat. We still don't know what's x, you know, because I took care of this variable, but I made this one got all messy. It got into a big mess. It's got all this stuff around it. So this type of equation is like watching kids. And I know you think that sounds strange, but think about it. If you have two kids that you're watching, and one kid is in the living room, and one kid is over in another room, and you're playing with this one, hi, how you doing? Here's a little doll. You know, we're playing dolls, right? And so you're hanging out and you're watching this one. Well, this one's getting into all kinds of trouble because you're not watching them. Trouble, 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 trouble. And so you hear the trouble and you run over there and you're trying to take care of that kid. And so then this one over here, he decides, oh, well, nobody's watching, so he's going to get into trouble, right? He's going to get into the candy dish. And so the problem is that they're on two different sides of the house. The best way to take care of kids is to put them on the couch, put on Barney, give them little sippy cups, and they'll sit there and watch Barney in one spot and make your life easy. When they're in one spot, they are easy to take care of. And you know what's also true? Variables, when they're in one spot, are easy to take care of. So let's take a look at our problem and see what we can do, right? So here's our 3x plus 7 is equal to 5x plus 1, right? And so I've got a variable over on this side, and I've got a variable over on this side, and I know I'm never going to be able to solve this problem unless I get them in one place. And so what I always want to do is try to move the smallest one. Because if you've got to move a kid from one room to the other, moving the smallest one is easier, right? Because they're less heavy. So move the smallest x. And I'm going to put the x in parentheses because sometimes it'll be an M or a Y or an S or, whatever. Okay? So which one is the smallest one? Well, the 3x is the smallest one. Well, how do I get rid of it from over here and move it over here? Well, the get rid of is our answer. I have to do its inverse. So I'm going to subtract 3x from both sides. Alright, so you're just going to subtract 3x from both sides. And what's the result of that? Well, these are additive inverses, so these will cancel out, and they literally cancel. And so there's nothing there. And then the 7 comes down because he has no like term. And then 5x minus 3x is 2x. And then the 1 has no like term, and so he comes down. And so now I have all of my kids in one room. I have them all on the couch watching Barney doing the sippy cup because I have the x just right there. And so now I can go ahead and undo my addition with a subtraction. Subtract 1 from both sides. And I'll get 6 is equal to 2x. And now I'm just going to undo my multiplication with a division, just like always. Divide both sides by 2. And so 6 divided by 2 is 3. And 2 over 2 is just 1. 1 what? 1x. And so x must be equal to 3. And now I know what x is. And this is what we wanted to know, and so this makes us happy. Thank you for watching this little tutorial on solving an equation on both sides, and we'll see you later.